Assalamualaikum. My name is Muhammad Iman Daniel bin Syafuddin. Today I'm gonna explain about chapter 6, that is mechanical base of human motion. In this chapter, we're going to learn about laws. What laws is about Newton's law. As you can see, Newton's law of motion, we have three. There is law of inertia as first, law of acceleration as second, and third is law of reaction and time. For starting of this chapter, I'm gonna explain about the first law, that is known as law of inertia. What is meaning of law of inertia? Law of inertia is mean like an object at the static position or at constant velocity. Unless there is a force applied to the object. Meaning that a motionless object will still motionless unless there is a net force. For example, when you're riding a bicycle at the constant velocity and then you suddenly brake the bicycle, that's what we call law of inertia. I'll give you another example, like someone standing or at static position inside a moving train, and then suddenly the train brake. When the train brake, there will be a force applied to that person body and will cause him or her to move a little forward. That's what we call law of inertia. A static object that stay motionless or constant velocity unless there's apply net force. That's what we call law of inertia. For now, we'll proceed to the second law of Newton of motion. That is law of acceleration. What is meaning of law of acceleration? Law of acceleration means that an object that receive a force will cause an acceleration. Meaning that a force is applied to the object and the object will produce an acceleration according to the amount of the force applied to the object. As you can see, law of acceleration, when an object and a force, when the amount of force is less than the body mass of the object, it will cause no acceleration because of the body mass is higher than the amount of force that apply to the object. For the law of acceleration, we're gonna look into two things, that is force and also body mass. As you can see, for the force, example like an object will produce a different amount of acceleration based on different amount of force that apply to the object. It means like the greater the amount of force that apply to the object, the greater the speed of the object is. That for the first thing. And for the second thing is for body mass. As you can see, like at my hand now, I'll have two different things that have two different body mass. As you can see, when I apply the same amount of force to these two objects, this object will cause a different amount of acceleration. Because of what? Because when I apply two same amount of force, this object has different amount of body mass. Like example, this watch is a little heavy than this pen. So when I apply the same amount of force, the pen, the amount of acceleration of pen is more higher than the watch. That's meaning of for the body mass of law of acceleration. Like another example, I will give you like, if 1 kg ball and also the 2 kg ball. We will have two ball. The same amount of force is applied to that ball, but the ball, they produce two different amount of acceleration. First kg ball will produce acceleration that 10 meter per second, and another ball, that 2 kg ball, is produced 5 meter per second. Okay, as you can see for the example, for the amount, okay, the more the body mass of the object, okay, we will must put more force to the object to give the object more acceleration. Okay, that's for the second Newton law of motion, that is law of acceleration. Okay, for the formula of law of acceleration, okay, we're gonna use F equal to ma. Okay, as you can see, F refer to the force we apply to the object, m is the mass of the object, and a is the acceleration of the object. Okay, as you can see, the relationship among the formula is, okay, the force is also depends on body mass of the object, and also body mass also depend on the force that apply to the object. Okay, as you can see, for the relationship, it means that, like, if the force is higher than the mass of the object, it will cause an acceleration, but if lower than the body mass of the object, it will cause no acceleration. Okay, that's for the equation of law of acceleration, F equal to ma. Okay, now is the last law, Newton's law of motion, that is third law, that is law of reaction. Okay, what is meaning of law of reaction? Okay, law of reaction is like for every action there is an equal and opposite reaction. Okay, meaning that when the object apply force to the another object, the second object will exert a reaction force that is equal in magnitude and opposite in direction on the first body. It means that, like, his first object is apply force to the second object, it will produce two different results. That is, the force will be equal, or the second object will be receive a similar amount of force but in negative. Okay, that's meaning of law of reaction. Okay, example I give you, like, football player. Okay, football player. Okay, football player A, football player A collide with another football player with an exert force of 450 Newton. Okay, the second player is receive the same amount of force that apply to the first football player, but in negative direction. It means that first player is 450 Newton. When the second player receive the amount of negative 450 Newton. Okay, that's meaning of law of reaction. Whether there is an equal or opposite reaction. So if equal, there will be the same amount of force, but in opposite reaction, the second will receive the same amount but in negative direction. Okay, that's meaning of law of reaction. Okay, for the equal and opposite reaction of law of reaction and time, it means that, like, okay, example, player A have 90 kg and player B have 80 kg. Okay, when player of 90 kg will give a force to the 80 player kg, the 80 kg of player will receive the same amount of the force but in negative direction, because player A have a little bit highest than a little bit high in body mass than player B. But if player A, I give example, like if player A have 80 kilogram body mass and player B have 90, if player A hit the player B, there will be an equal force, meaning that because the player B that is receive the force, their mass is a little bit higher than the player that give force. Okay, that's meaning of equal and opposite reaction. So if A have a bigger mass than B, and then A will give B a force, then the B will receive the same amount of force but in negative direction. But if A have a lower mass than B, and A will give receive to the B, so for both of them will receive a equal force. Okay, that's for equal and opposite reaction in law of reaction and time. Okay, that's all for the Newton's law of motion. That the three, that is law of inertia, law of acceleration, and law of reaction and time. Okay, for now I will proceed with mechanical behavior of bodies in contact. Okay, as you can see, there is four. There is friction, momentum, impulse, and also impact. Okay, for now I will explain the first, that is friction. Okay, as you can see, what is friction? What is the meaning of friction? Okay, friction is a force acting over the area of contact between two surfaces in the opposite direction. Okay, meaning that like a two object. Okay, like now I have a book and a watch. Okay, so you can see. Okay, the two object that contact over the surface of area, but the object move in the opposite direction. Okay, meaning like that, like this. Okay, this is what we call friction. Okay, if two object will move toward the same position, there will be no friction like this. Okay, if the book and the watch move in the same movement, there will be no friction. But in the opposite direction, there will be a friction. Okay, that is meaning of friction. Okay, for the example of the friction. Okay, first, as you can see, if the object like watch, okay, at top of the book. Okay, as you can see, if there is no force applied to the object, there will be no friction, meaning that the object will stay at the static position because there is no force applied to the object. Okay, and then friction, as you can see, if you apply a small amount of force in the object, it still will not move because if the force is less than amount of friction force, there will be no motion because when you apply a small amount of force on the object that have a greater amount of friction, the object will not move because of the amount of friction force. Okay, and then also if we put a little more or a greater force at the object will move but little bit, and then that's what we call maximum static friction. Okay, meaning that if we apply a greater force to the object and then the object start moving but a little, and then that is when occur what we call static friction. I mean that the force of the friction will occur. Okay, for the last for the friction is, okay, as you can see, we apply a large amount of force to the object, and the object will move, Okay, that's what we call kinetic friction. Kinetic friction, constant magnitude friction. Okay, they generate between two surface in contact during motion. Okay, for general in friction, okay, if the object is on the same contact of area but moving in the different direction, like opposite direction, it will cause a friction. But for the static object that is have friction with the floor, if there is no force applied to the object, it will not move. It will not give any motion. But if we apply the amount of force that is greater than the amount of friction force, okay, it will move the object. Okay, that's meaning of friction. Okay, for the second is about momentum. Okay, so you can see momentum can be defined generally as the quantity of motion that an object possesses. It means like quantity of motion inside the object. Okay, quantity of motion measured as a product of body mass and its velocity. Okay, I'm gonna explain about this. Okay, example like a static object with zero velocity has no momentum. Okay, so you can see change in body momentum may caused by either change in body mass or change in velocity. It means like momentum can be changed either by body mass or the velocity of the object or the person. Okay, but in most human movement situation, change in momentum result in the change of velocity. So it means like in human, we will be more look at the change in velocity for the momentum, but still look in the body mass. Okay, for example, for the momentum. Okay, two hockey player that have a different body mass. That is, player A 90 kg and player B is 80 kg. Okay, so you can see that 90 kg player have a velocity of 6 meter per second. And the 80 kg player have a negative 7 meter per second. As you can see, when both of them collide and give impact, the player that 80 kg will give more momentum, and the player of 90 kg will receive more momentum from player B. And for the moment and for the movement, player B that 80 kg will be moved a little forward because of his velocity, because the velocity is 7 meter per second, and player A has 6. So the player B have more velocity than player A. So player B will give more momentum to the player A than player A give to the B. Even though they have a different body mass, that is player A is more heavy than player B. Okay, as you can see, in human, we'll be more overlook at velocity for the change of momentum. But if the person have a lesser amount of body mass, will not affect the momentum if the velocity is high. So it's like a normal body mass. Okay, that for the momentum. Okay, so as you can see, for overall momentum is like when a person collide each other, different amount of body mass and different amount of velocity, and as you can see, for the object, we will look between body mass or change of velocity, but for person, we will look more to velocity but still look at the body mass. So like I give example at hockey player, as you can see, player A have 90 and player B has 80, but player B have 7 meter per second, but player A has 6 meter per second. So player B will give more momentum to the player A because it have greater amount of velocity than player A. Okay, that's for momentum. for the formula of momentum is m1 v1 plus m2 v2 equal to in bracket m1 plus m2 bracket velocity. Okay, that's the formula for momentum. Okay, for the third one is impulse, that after momentum. Okay, so you can see impulse is like change in momentum that depend on the force, and also length of time over. Okay, it's mean that different amount of force and also different time interval that occur change in momentum. Okay, that is meaning of impulse. Okay, when an impulse act on the system, the result is change in the system total momentum. Okay, and for the equation, as you can see, impulse equal to Ft. Ft is mean like force and time. So as you can see, impulse is a change in momentum that depend on the force and also time. Okay, for example, I give to you for the impulse is like when small force acting over a large time interval. Okay, meaning that you apply a small amount of force to the object, but the object move for a large time interval. Okay, I give example like a golf ball that you hit will roll across a green, will roll across the green until the ball lose the momentum, because its motion is constantly opposed by the force of rolling friction. Okay, meaning that, okay, so you can see for the golf ball, okay, you give a small amount of force, you hit the ball with the small amount of force, but the ball will roll for over a large time interval. It means that it will roll for a longer time, but it will still lose momentum, and then the ball will stop, but it's still acting over a large time interval. Okay, for the second example is a large force acting over a small time interval. Okay, for example like baseball player. Okay, so you can see when they hitting when they hitting the ball, they will give a large force at the baseball bat over a small time interval. Meaning that small time interval of the baseball player is the duration between his or her bat until hit the ball. Okay, meaning that large force is applied to the bat, but small time interval is acting at the ball. Okay, meaning, okay, for the two example that I give is if small force acting over the large time interval, the momentum is low. The momentum is low because of the small force. Okay, for the large force acting over small time interval, the momentum is high. Okay, that's for the impulse. Okay, so for the last after the impulse is about impact. Okay, and also impact is the last subtopic in this chapter. Okay, so I'm gonna explain about impact. Okay, so you can see what is the meaning of impact. Impact is collision. Collision characterized by the exchange of a large force during a small time interval. Okay, meaning that type of collision between object A and object B. Okay, that is meaning of impact. Okay, now I will explain about perfect perfect elastic impact. Okay, what is meaning perfect elastic impact? Okay, perfect elastic impact is mean like when the object give impact to the surface at some amount of velocity, the object will be bounced back at the some amount of velocity. Meaning that like tennis ball to the surface of the ground. Okay, so you can see when we release tennis ball at like 1 meter height, okay, the tennis ball will be bounced back at some velocity, but different amount of velocity. So as you can see, this is what we call perfect elastic impact. After the object is impact with the surface, the object still receive a velocity, but in less amount than the object release. Okay, that's what I mean by perfectly elastic impact. Okay, meaning that like that. Okay, for the second one is perfect plastic impact. Okay, so you can see perfect plastic impact. Perfect plastic impact is total loss of system velocity. Okay, so you can see total loss of system velocity, meaning that when an object hit the surface at some amount of velocity, when they contact the surface, the velocity automatic loss. It mean like the velocity when hit the surface, velocity is totally become zero, because the surface or the object. Meaning like, I'll give you an example like plasticine or what we call clay. Okay, so you can see plasticine, when we throw or release to the ground, the plasticine will not bounce back at the same velocity because of perfect plastic impact. After the plasticine hit the surface, the velocity of the plasticine will become totally zero. Okay, that's what we mean by perfect plastic impact. As you can see, it's not like the object. It can be surface. Like example, like you throw a ball in the ground that have sand, like sand. As you can see, if you throw a ball or release a ball at that type of ground or type of surface, they will absorb the velocity of the ball, and the ball will not be bounced back because of the sand. The sand will absorb all of the velocity that the ball has. Meaning that if you release a ball at 1 or 2 meter height, you release the ball onto the surface of sand. Okay, the surface will absorb all the velocity of the ball, and the ball will not be bounced back because velocity is totally lost. Okay, that's meaning of perfect plastic impact. Okay, that's all from me. That's all from chapter 6, that is mechanical base of human motion. Okay, so as you can see, we have covered all subtopic in the chapter 6. That is, first we cover about the laws. That is Newton's law of motion. That, okay, as you can see inside, there is first, second and third law of motion. That is law of inertia, law of acceleration, and law of reaction. Yeah, and then we covered about the mechanical behavior of bodies in contact, like friction, momentum, impulse, and impact. Okay, that's all from me from chapter 6, mechanical base of human motion. Okay, thank you.